Hello everyone, this is Mustafa. In this video we are going to talk about how to integrate Qt to our distro as part of our lecture called Applied Yocto project using Raspberry Pi 5. Qt is, as you might know, a very popular graphical framework in the GNU Linux ecosystem. In the older days, other frameworks such as Qt6 was being used a lot, but now first thing that comes to mind when we talk about a graphical framework is Qt. And Qt based development is not part of our lecture, but we will see in this lecture how we can integrate it to our image. We have mainly three layers that I know of when we are talking about Qt support in Yocto. We have Meta Qt5, we have Meta Qt Extra, and then we have Meta Qt6. If we are developing an application that uses Qt5, we should integrate Meta Qt5. Whereas if we are developing an application that uses Qt6, we should integrate the Meta Qt6 layer. In these layers, basically, we have many recipes to support building each of the Qt modules, and also we have some classes to support building using Qmake and CMake build systems. In our example, let us take simply a Meta Qt6 layer to integrate, so we can start exploring now. So first, what I'm going to do is I'm going to show you how Meta Qt6 layer looks from our favorite website, which is Open Embedded Layer Index. Let us go inside and simply search for Qt6, and here you can see the Meta Qt6 layer, and if you scroll down you will see what sort of recipes are provided with this Qt6 layer. As you can see, basically every Qt module is covered here. Qt base is the main one, and then we have all these additional modules that are covered. For example, if you want to implement some connectivity support using Qt, then you will be also integrating this one. But luckily, it is really easier for us. Meta Qt6 layers only depend on simply these three layers, which we already have: Open Embedded Core layer, Python layer, and OE layer. Alright, so first what we are going to do is we are going to remove support for the desktop XFCE, because in the last lecture we added the support for this XFCE desktop, but we don't want that in our embedded distribution. It was only a demonstration. So first thing I want to do is get rid of this layer, save this file, and also we have this Qt5 layer we experimentally added, so let us also get rid of this one and go to the local conf, and simply what we can do is we can comment, I believe, this, and that will be it. So these were all the things that we did in order to add the XFCE support. Alright, so first let us go to this Meta Qt6 layer and let us copy this clone. Let us check if there is a ScartGap branch or not. Apparently not. So we can search which sort of version, Yocto version is. Oh, these are Qt versions, not the Yocto versions. Alright, that's good. Alright, in that case, let us say that we want to support 6.5, right? Let's go back to our Pocky distro. First, let me remove the Meta Qt5, and then let us clone this 6.5. as you can see, we have the clone now, we have the meta Qt6 layer. Now what we want to do is we want to add this to our bb layers conf, and in order to do it, I just simply copy this and I add it like so. All right. I'm thinking if I am missing anything, but I don't think I am missing anything. So we just added the layer and then we have populated our bb layers variable, and I think we are good to go at this stage. So next up, what we want to do is we want to create a simple Qt demo application so that I can also show you how to write a recipe using Qt Yocto infrastructure. Then you can implement also your Qt applications. So let us open our Qt creator software. As you can see, it is here. So let us create a project. It will be a Qt quick application in case you want to use QML for the graphical parts. Alright, so let us continue with the Qt quick. So I have a workspace for the Qt, but in order to demonstrate, I won't be using this. And let's name our project Yocto Qt6 demo, maybe. So let us browse and select an appropriate place. Let us go inside our Poki and let us go inside MetaMons, our own layer. Let us create a folder, our category, which will be recipes apps, and inside let us create Yocto Qt6 demo, and inside let us create files folder as we did previously, because this is the one that is recognized automatically. And then what we should do is simply create another folder, or not, actually let's not do that, so it will create automatically under it. So we will be creating our project under this recipes apps Yocto Qt6 demo files, and then the name of the project will be Yocto Qt6 demo. So I'm expecting actually a folder to be created inside this. Let us move on. We don't want any virtual keyboard, and we don't want to use the Qt Design Studio at this stage, and we can select a desktop kit. It doesn't matter because with Qt we will be cross-compiling it already. Alright, so our application has been created. If I click run now, I'm expecting a white window. As you can see, just for demonstration, let us make this red so that if we simply cross-compile this, we can see from the Raspberry Pi a red screen. Let's check if this works. Alright, it indeed works. So that's good. We have our basic application. Let us close the Qt creator because we don't want to do anything else here. We just want to cross-compile it using Bitbake. Let's check the files that are created. Okay, this build folder is also created because we have built it once, but it doesn't matter. It can be there. If it causes any problems, we can delete it. So let us keep it for now. And here, yeah, we can see the main files that are important are main CPP, main QML, and this CMake lists.txt for the CMake integration. And we can simply show you the CMake file. It is automatically generated, and we don't need to do anything else here. Alright, so let us go back and create our recipe. In this case, we will be creating our recipe under this file. So let's select the new file, Yocto Qt6 demo. Let's call it 11100. Inside, we have to do a few things. First, what we want to do is we want to give a summary or a description, and we can say that a recipe to demonstrate how to integrate Qt6 applications using Yocto project. Of course, we have to give it a license, and then we have to specify our build time and runtime dependencies. This part is especially important because we will be populating some values here. Alright, so let us think about it. Our build time dependencies. First, we are using CMake, right? Therefore, CMake for the build, main build system in our case. Therefore, for sure, we have to add CMake here. What else? We will be using Qt module or library in order to compile our application. So for sure, we also have to include Qt6. Qt6 module is simply the first thing that you have to integrate when you are compiling something with the Qt. And the same should also be visible for the runtime dependency, because we want Qt6 to be installed in our system for it to properly work. Therefore, we will be adding also Qt6 in the runtime dependency. Next up, we have to add Qt declarative, which is basically QML support. As you recall, we have created the project with the QML support. Therefore, we have to include the Qt declarative also. Alright, I might be forgetting some things to add here, but we can simply move along with our development, and if we get a build error, we can make these small modifications. It's fine. Next up, we have to give a source URI variable. So let us do that. In our case, that will be simply this folder, Yocto Qt6 demo. And since files, I'm assuming, is already recognized, we don't need to give a files extra paths variable prepend statement over here in the very beginning. We just can use these files since it is already recognized. We can give our folder directly. So let's go ahead and do this. Yocto Qt6 demo. Alright. And then let us give a folder to the source directory. In our case, it will be simply something under work dir with the package name itself actually. So let's do something like this. And then final thing, which is important, we have to inherit the BB class that is provided with this meta Qt6 layer in order to make this Qt6 CMake build happen. So let us search for a class like that. Let's go inside classes, and immediately I'm recognizing two. First is Qt6 CMake BB class, and the second is Qt6 QMake BB class. Since we are using CMake, we can simply inherit this one. So I will be doing this, but I will be also adding this package config that we mentioned before, because it is, in my opinion, a good practice to add it. So first package config, then only the class name, which will be Qt6 CMake. Alright, just a little bit of information. So we are making the CMake build, right? If we want to pass any variable to the CMake, we can use one variable which is called extra OE CMake. If it was a make file, we could use this extra OE make. That's something really important to keep in mind. Therefore, for reference, I will be adding this. But what to add, we will see if we get any error. We can add some things from here to the CMake file in order to fix things. All right. So let us run it. Actually, the cooking of this recipe will take a long time, since we did some important changes in our local conf, and also we would like to delete this distro features append x11, or simply comment it. I forgot about that. So since we removed the XFCE support, I'm expecting some packages caches to simply be deleted. Therefore, it is going to take some time, but we have some time. So I will start the build and cut it to where the build is finished or build gave an error, so we can have a look together. In that case, let us start it and let us give a break. And what we would like to do is actually add this to the image. So let's go ahead and do this real quick. Let's check the indentation. It looks correct. Alright, let's start our first attempt, and I will see you when it finishes. Oh, it really finished really quickly, so let's check the error. Alright, so it is basically saying that the 6.5 layer, Qt6 layer, is not compatible with our Yocto branch, which is ScartGap. That is interesting. We have several solutions that we can attempt to fix this. First, ugly solution, we can simply remove the statement that says that gives this compatibility, or we can add this ScartGap branch there. But first, I would like to fix this in the usual way, which is to find a repository that supports this ScartGap. So we will be doing some experimenting with this branch in order to check if we can find any branch that supports this ScartGap. So let me check this 6.8. Let me go to the tree, conf, layer conf. Alright, we have immediately found it. So as you can see, with this variable in layer conf, simply the layer compatibility information is given, and here we can see ScartGap in this list. Therefore, we can simply remove our 6.5 branch and copy or clone the 6.8 branch. So that's what I'm gonna try to do actually. But what I'm seeing is 6.8 is a very recent branch. So let us check if this 6.7, which is, I hope, more established. If 6.7 indeed has this card gap support, if there is card gap support, and indeed there is, I would like to actually use this one instead. So let's try it one more time. Yes, indeed there is 6.7 here. Conf card gap support is here. All right. So let's go to the summary and copy our repository address again, and then simply go back, delete what we have just cloned, and git clone 6.7. Let's go ahead and do that. All right, we are set. Let us do this one more time. Alright, so the build has been completed, but we have got an error that simply says Qt is unable, the CMake is unable to find the module quick, which basically means that this Qt declarative is not working for the build dependency. So what we could try is we could, instead of this one or alongside this one, we can also add the native version of this package, because most likely the CMake when building uses the native, so host version of the CMake dependency package. That we can try. So in that case, what we are going to do is we are going to say Qt declarative native, and it gave us one more clue. Let me try to find this. The clue is that it is saying configuring with this option might reveal details why the package was not found. So I think it is a good idea to also simply pass this to the CMake in order to find why the package was not found if our supposed or solution we thought is not working. So let's go ahead and also do this. We will simply use this variable extra OEC make. I'm gonna paste it here, and then simply I will be recooking the recipe. Right, sounds like it is running well. We didn't get any configuration error as we did, and the install and package is also completed. So it seems like this Yocto Qt6 demo that we try to integrate is progressing well, but this Qt declarative needs to recreate some RPM packages. So once all this is complete, I think we will be ready to move forward. Alright, so I have interrupted the build because I have also noticed something else. We do not have a, let's say, desktop compositor at this moment in our system. No X11, no Western, but we will need to simply run this Qt application by using some compositor. So the way to easily do this when you don't have any desktop or any compositor is to simply use eGLFS. eGLFS is a platform plugin in Qt, and you just have to enable it and do nothing else. It's really easy. Let us go down to Qt based recipe and I will try to explain it. Let's go to recipes Qt. Qt6.include, I believe it was here, I'm not so sure, but let us check. Alright, it's not here. Let's go to Qt base git. Qt basically uses this Qt installation or Qt software package basically uses package config options, and these package config options are simply denoted as such, as you can see with my cursor, and it basically says if ltcg package config option is enabled, then simply pass this command line to the build system. Same goes for every other package config option that you are seeing. For example, if this static is simply enabled, then the first one will be passed. If it's not enabled, then the second one will be passed. And we are trying to find this eglfs package config option simply. In order to be able to use this, what is called a platform plugin, we need to enable this eglfs in the Qt base. So there is kind of two ways we can achieve this. One method is, in our layer we can create a Qt base git bb append file and simply add this eglfs to the package config variable. The other method is actually simpler. In the other method we can simply go to our local conf and we can type as such. So we will say package config, let's not forget the E, then we will say append, then we will follow up with pn dash, which basically means package name. Then here we need to give a package name. So in this case we want to extend the package configuration for the Qt base package, right? So we should formulate our variable as such, package config append pn dash Qt base. Then we will continue with equals and we will simply add eglfs here and nothing else. If we do this, then this option will be enabled. Then the first one before the comma will be simply passed to the build. If we didn't have this, then feature eglfs equals off. This second portion would be passed to the build. This is something really important when you are configuring stuff. This sort of package configuration is also used in GNU Auto Tools builds. For example, any build system that uses package config, it is important to keep this configuration in mind, and usually in GNU Linux this package config is used heavily. Alright, since Qt is a huge module consisting of many features, some of the features come by default, some of the features you have to enable later on, and this is just an example how we have enabled the eglfs from only using localconf. The same thing we could have done simply by creating a Qt base git bb append file, but under MetaMoz. So what we should have done in that case, we should have created, we should of course keep this similar folder layout. So I believe it would be recipes Qt. Let's check from the meta Qt6. Yes, it will be recipes Qt, then Qt6. So just create a Qt6 folder, and then inside we would have created this Qt base git bb append file, and simply inside of that file we should have copied this statement, and inside we can have this statement, and we can remove this package name part, because the build system already knows that it is appending the Qt base, so this would work if we had an append. But in order to keep everything in the same kind of place where we can see everything, I prefer this option, at least for the beginner. But if you'd like, let's do the second approach, since this is a bit more fancy way to do it. Right, let's remove this then. Let's have this second approach. Actually, let's have this commented so that we can remember there is also this option. And let's again restart our image recipe. Now, since this will configure the Qt base, I expect some more time, because Qt base will most likely be recompiled, so I will see you when it finalizes. Alright, so the build has finally succeeded. I didn't get any further errors. I tried to simply run it twice or 3 times. Actually, let us also start the image recipe to see if we have a problem there. But in the meantime, I can explain what I did more. So I did a few more quick changes. First of which is I switched the Qt6 branch to 6.7. What I did was basically go to here and I simply git cloned with the same command, and I used the branch 6.7.0. That's the first thing that I did. And then what I did is, if we take a look at the local conf, there's not much changed here. Actually, we are still using this fake KMS driver, the same one that we used for the XFCE, so nothing changed there. But we had also added this let's say package config append to the Qt base. In this case, I have added eglfs, KMS and Linux frame buffer. So I tried a few more things to add, but then I realized that the Qt Quick is not built with certain platform plugins. So if you are also targeting this eglfs, the same one as me, I think this should be good enough for you. eglfs and KMS should be good enough. Linux frame buffer, it's optional in my opinion. So if you ever require it, it's good to have. Other than these, I have added some BB appends simply. Let's go back and you will see the same exact pattern. So you can see that I have simply disabled some tasks. This is the way how you can disable a task from a BB append file. Basically the task name, and then in these parentheses write no exec equals 1. That means that for this Qt base package, this task won't be executed. And the reason why I simply got rid of these 2 tasks is because this is regarding the testing, and testing is more required when you are planning to simply change the source code of the Qt itself. So in my case, I'm not going to change the source code at all. I'm just integrating something, and I realized that this sort of p-test tasks take a huge amount of time during the build. I actually had to do several builds, and in each time these 2 tasks were taking huge amount of time, so I decided to simply disable these 2 tasks for a few software packages. The first one that I did it for was Qt base, the second is Qt declarative, the third one Qt shader tools, and the fourth one is Qt svg. Actually, these 2 are simply dependencies to the Qt declarative, just to let you know. So all in all, a local conf is not changed. We have these 2 lines added, and we have these ones that are commented simply. We have removed these ptest task execution from several software packages. And on top, what we did is simply we changed the Meta Qt6 layer. Actually, it was more of an experimentation, because I did this Qt6 porting to the Raspberry Pi 5 before and I didn't have any problems, but now trying it a second time with different branch, and you have seen the kind of errors that we got, but a little bit of digging deep and trial and error leaves us this correct build. Finally, we have this Qt6 that is embedded in the image. We can even check it ourselves just to make it sure. Oh, not here, sorry. Let's go inside our rootfs, and as you can see, the application is deployed. And if I check the file here, it is indeed cross-compiled for the Raspberry Pi, so ARM64. So we are good here. One more tip for you. I won't be simply going through and taking a video of my screen showing you how this Qt application works. But one tip for you, basically what you have to do when you are inside the Raspberry Pi, you will go usr bin and the application name, Qt6 demo, and then you have to select the platform plugin. Otherwise it will default to the default platform plugin. So since we don't have X11 support or anything, it will most likely give an error if you don't have this flag. So what you have to do, from inside the SSH terminal and or the serial console, just go ahead and give this platform option to the executable and then say eglfs. With this, you should be able to run the Qt application. If you have a screen connected to the Raspberry Pi, you should see it on the screen.